Hello everyone, and welcome back to our practice video once again. In this practice video, I mentioned last time that we're going to find the missing angle, right? But before that, uh, let's try to solve this problem first. I actually forgot. Okay, forgive me, right? Let's solve this problem first, okay? In here, your objective is find each of the triangle's x component and y component. That's it. Actually, this is by far the easiest for me. You know why? Remember that if you're going to find the x component and the y component of a right triangle, first and foremost, you need the hypotenuse. And second, we're going to use two trigonometric functions, which are cosine and sine. Okay? So if you're going to find an x component and a y component of a right triangle, okay, you're going to use x is equal to h times cosine theta, and your y as h times sine theta. Okay? So this one by far is the easiest. All you need to do is just get a calculator. Okay? So let's give it a try on this uh, leftmost triangle. Your hypotenuse here is 17 and the given angle here is 27 degrees. Okay, so what are we going to do? So what we're going to do, we can now substitute. So x is equal to your hypotenuse 17 times a given angle, it's 27 degrees. Okay, so your x is here. Okay, your x is here and your y is here. Okay, so what will be the answer? Let's use our calculator. So 17 cosine 27 degrees, you will have approximately at 2 decimal place. This is 15.15 units. So approximately 15.15 units. Okay. Now, how about for your y component? This one, okay, just substitute 17 times sine of 27 degrees. So here we have 17. Oh, wait, no. We already wrote that. So what we're going to do is we're going to use our calculator here. So here we will have approximately in a 2 decimal place, this is 7.72 units. Okay? So your y here, it's 7.72 units. That's it. Okay? Now, how about this one, the middle part or the middle right triangle? Okay? Uh, it's still the same thing. Just use this formula, okay, to find your x and to find your y. Okay? So let's start first with your x. So your x is where again? It's here. And your y, it's here. Okay, on the top. Oh, wait. For what? Sorry. Let me erase this one. This one. So x is here and y is here. So we have x. I hope my handwriting is visible because I think this is the only color that I can relate to this triangle, okay? So x is equal to your hypotenuse 15 times the angle cosine 35 degrees. So here, what we'll have here is we have 50, wait, sorry. I haven't seen the answer yet in my calculator. This is approximately in 2 decimal place. This is 40.96 units. 40.96 units. Okay? So this is, once again, 40.96 units. Now, how about for your y? So 50 times sine 35 degrees. All right, 50 times sine of 35 degrees. So here, what you will have, it's approximately at 2 decimal place. This is 28.68. All right, 28.68 units. Okay, 28.68 units long. Done. We're good. But how about to the last part? The rightmost right triangle. How are we going to solve that? It's easy. Okay? Same thing, same formula. Okay, wait. I accidentally erased the formula for your x component. So h times cosine theta. Yeah. How will you find the x component and the y component? Yeah, easy, easy. Just find the x, which is this one, because x is horizontal, right? And your y is here. And just substitute the angle here, right? No, no. Here you will have one rookie mistake here. Do you know why? Okay. You see, if you're going to compare the other two problems, where is the acute angle located? It's below, right? Below or on the base level. 47 degrees here, 35 degrees here, right? So yeah, that's good. This one, on the other hand, it's not on the base level. So what are we going to do? In here, we have two ways. One, let's find the angle here. Okay, let's find the angle here. Okay? The other way around, just imagine you're going to flip this right triangle at 90 degree. Okay? So we have two ways. And it's up to you if you're going to pick or select which one of the ways that you prefer the most. Okay? Let's start with the first way. Here, the angle here, which is a question mark, you're going to find that. Okay? Why though? Why? Because if your x is always at the horizontal and your y is always at the vertical side, the first thing to do is that you must have angle, an angle beside with your x. Okay? Beside with x. Because if you're going to observe here in the example, your x is 15.15. And beside it has an acute angle. Here, the same thing here, 40.96 units. It's beside with the given acute angle, which is 35 degrees, right? So for you to find your x component here, you must have an angle here, beside it, okay? Beside it. But as you can see, we have no acute angle here. So we're going to find that acute angle. By how though? First and foremost, we must state the given angles here. We have 70 degrees and we have the right angle here, which is 90 degrees. Okay. So to find that missing angle, let's recall the the sum of all interior angles of a triangle. In any triangle, whether if it's scalene, obtuse, acute, or right triangle, any triangle, if you're going to add all of the interior angles, it should always sum up to 180 degrees. Okay? So for example, I have this angle. Okay? So this is angle A, angle B, angle C. For example, okay? For example, if you're going to add all of these angles, in fact, these are what you call interior angles because it's inside of the shape. So if you're going to add them, angle A plus angle B plus angle C, it will always sum up to 180 degrees. Okay? We can relate that onto our given problem. Okay, we can relate it to that. So here, we have the missing angle here. So it's theta plus the right angle here, 90 degrees, plus the angle here, which is 70 degrees. So again, it should sum up to 180 degrees. So we can use this equation to find our missing angle. So what is 90 plus 70? I think that's 150 if I'm correct. 90 plus 70. I'm just making sure. It's 160. It's 160. 90 plus 70 is 160. Okay, 160. So we will transpose 160 to the right. We will have theta is equal to 180 degrees minus 160 degrees. So getting the difference of the two, we will have 20 degrees as a result. So therefore, the angle here missing, or beside with the x rather, it's 20 degrees. It's 20 degrees. Right, let me just erase this one. Okay, so this is 20 degrees. So let's substitute. So x is equal to your hypotenuse, 100 times cosine of 20 degrees. Okay, so what will be the answer here? So 100 times cosine of 20 degrees, this is approximately at 2 decimal place, this is 93.97 units. Now for your y, we will substitute 100 times sine of 20 degrees. So approximately at 2 decimal place, this is 34.20 units. Okay? So your x here, it's 93.97 units. And your y here, it's 34.2 or 20 units. Okay? And yay, actually that's good. Now, that's a first way. Now we can have the second way. The second way is just oh, I erased everything. But yeah, it's okay. So the second way here, it's try to rotate this one in 90 degrees. So from here, if you're going to rotate from this point up to 90 degrees, what we will have is this. Okay? We will, no, that sounds wrong. We will have this one instead. Okay, this one. There we go. So this is 70 degrees right angle. Okay, and this is 100. So if you're going to observe, I rotate this one into 90 degrees exactly. Okay, to the point that this side became the base side of the right triangle. So what are we going to do? In here, as you can see, now that we rotate it into 90 degrees, this is already your x. Remember, your x is the horizontal, and here your vertical side here, this is your y. With that, we can now substitute the what? The formulas here. Okay? Since your x is beside with the acute angle, so we can now simply substitute. So this is easy. Okay? So you have x is equal to 100 times cosine of 70 degrees. So this is approximately 100 times cosine of 70 degrees. This is approximately 34.20 units, which is just the same as what? As 100 times sine of 20 degrees. Okay? So it's amazing actually. So now how about for your y? So your y is 100 times sine of 70 degrees. So this one, we will have approximately 93.97 units. That is your y. See, this is just the same as what? The same as x is equal to 100 times cosine of 20 degrees. 100 cosine of 20 degrees, it's approximately 93.97 units, which is just the same as our results. Okay? They're just the same, you know? So there, we learned something, like, it seems like in some way they're the same, right? So we will discuss that in a future lesson. And that will be the properties of a trigonometric function. And after that, we can now proceed to the what do you call this one, to the other topics. Okay, but now you get the idea. So that will be all, guys. Okay, so next video is another practice video about getting the angle in the right triangle. Okay? So see you soon.